A few months ago, a developer needed a sentiment model. They searched a popular model hub, found one with a friendly name, thousands of downloads, and a clean-looking model card, and they did what all of us do. They pulled the weights and shipped it. What they didn't see was that the file wasn't just weights. Loading it ran code, and that code quietly reached out to an attacker's server the moment the model was imported. No exploit, no phishing email. The developer invited it in, because on a model hub, the malicious thing and the legitimate thing look exactly the same. Here's the shift for today. In modern AI, almost nothing in your stack was built by you. The model, the weights, the training data, the libraries, the plugins, you inherited all of it from strangers. So in this episode, we secure the supply chain, how to know what you pulled in, prove it's what it claims to be, and stop the poisoned link before it reaches production. Let me tell you where we're headed. By the end of this episode, you'll be able to draw the AI supply chain from dataset to hub to your app. You'll be able to name the 4 headline risks: tampered weights, malicious or trojaned models, typo-squatted packages, and license traps. And you'll be able to put a named control on each one: provenance, signing, scanning, an AI-BOM, vetting, and pinning. To frame it, we're still in domain 2, the big 40% domain. A few episodes back, we secured the lifecycle you own. Today is the opposite. It's about everything you don't own but depend on anyway, because modern AI is assembled out of third-party parts. And remember the lens of this whole series: architecture and frameworks. A supply chain is an architecture, and securing it isn't a gut feeling. It's provenance, verification, and an inventory you can actually query. Every control we name will hang on a framework you can cite. So let's walk the supply chain left to right and make it concrete, because every node here is a trust decision someone made, often silently. It starts with datasets: scraped corpora, public datasets, labeling vendors. You rarely see the raw data that shape the model. Next, pre-trained models and their weights. That's a multi-gigabyte binary of learned parameters. You can't read it the way you read source code. You mostly trust the name on the box. Then the ML libraries and frameworks, your training and inference stack, plus its deep dependency tree, all pulled from public package registries. Then model hubs. Think of them as the app stores for models and datasets. Convenient, open, and largely self-published. Downloads and stars measure popularity, not safety. And finally, plugins and MCP servers, third-party tools you bolt onto the model to give it new powers. The big idea tying all of this together is transitive trust. When you adopt a model, you don't just adopt that model. You adopt its training data, its dependencies, and its publisher's entire security posture, usually with no contract and no review. That's exactly why OWASP put supply chain on the LLM top 10 as LLM 03, because the risk isn't only in your code, it's in everything your code stands on. One thing worth flagging for the exam: treat a pre-trained model the same way you'd treat a third-party software dependency you didn't write, because that is precisely what it is. The mental model that scores points is this: every external model, dataset, library, and plugin is untrusted until you've established its provenance and verified it. Convenience on a hub is not a security control. Now, where does this actually go wrong? 4 headline risks. The first is tampered weights. The model file gets modified after the fact. A backdoor or trigger is baked into the parameters, or the loader itself is rigged to execute code the moment you import it. The second is malicious or trojaned models on hubs, a model published specifically to be downloaded and trusted. Some are weaponized serialization formats that run code on load. Others behave perfectly normally until a hidden trigger fires. The hub is just the distribution channel. The third is typo-squatted ML packages. An attacker publishes something like TensorFlow or PyTorch utils, hoping you fat finger a pip install. One bad dependency in your training or inference image, and the whole pipeline is compromised. That's a classic software supply chain attack, now aimed squarely at the ML stack. And the fourth is the quiet one: license and data rights traps. A model or dataset whose license forbids commercial use, or that was trained on data the publisher had no right to use. No code executes here, but you inherit legal and compliance exposure and possibly a model you'll have to rip out later. Provenance covers your rights, not just your integrity. And if you want the adversary's name for all of this, MITRE Atlas calls it ML Supply Chain Compromise, technique AML.T0010, covering the compromise of ML software, data, and the model itself on the way to you. So what is model provenance? It's the documented, verifiable record of where a model came from and how it was made, who published it, what data and base model it was built on, how it was trained, and an unbroken chain of custody proving the file you're loading is exactly the one they released, unmodified. No provenance means no basis for trust. You're just running a stranger's code on faith. Now let's pair every risk with a control, because that's the rule of this series, and the supply chain makes it clean. Provenance and vetting answer malicious models and license traps. Pull from trusted, authenticated sources. Review the model card, the license, and the publisher, and prefer models with a documented lineage. Signing and verification answer tampered weights. Verify cryptographic signatures and checksums before you load anything, and prefer safe serialization formats that don't execute code on load. Don't trust a file just because the download finished. Scanning answers Trojaned models and bad packages. Scan model files for unsafe code and known malicious patterns, and scan your dependencies for known vulnerabilities and typo squats, exactly the way you scan application code. Pinning answers the whole chain. Pin exact versions and hashes of your models, datasets, and libraries so that what's in production can't silently change underneath you. A floating dependency is an open door. And the control that ties it all together is the AI-BOM, because you can't secure what you can't inventory. As for frameworks to cite out loud, OWASP LLM03 names the risk, and NIST's Secure Software Development Framework, SP 800-218, along with the SBOM practice, is the proven software world playbook. Provenance, integrity verification, and a bill of materials that we're simply extending from software to AI artifacts. So what is an AI-BOM? An AI bill of materials is a complete, structured inventory of every component that goes into an AI system. The models and their weights, the training and fine-tuning datasets, the libraries and frameworks, and the plugins or external services it depends on, along with each component's version, source, license, and provenance. It's the SBOM idea extended to AI. If a malicious model or a vulnerable library is disclosed tomorrow, the AI-BOM is what lets you answer, are we affected, and where, in minutes instead of weeks. One more thing worth flagging for the exam. Know the AI-BOM as the AI counterpart to the SBOM, and know why you'd want one. Rapid impact assessment and provenance when something in your supply chain turns out to be compromised. If a scenario describes a newly disclosed malicious model or a bad ML dependency, the exam-favored answer is the one grounded in inventory plus provenance, knowing what you have and proving where it came from, not scan harder after the fact. Let me leave you with 3 takeaways. 1. In modern AI, almost nothing in your stack was built by you. The model, the weights, the data, the libraries, the plugins are all inherited, and inherited means untrusted until proven otherwise. 2. The headline risks are tampered weights, malicious models on hubs, typo-squatted packages, and license traps. So pair each one with a control: provenance, signing and verification, scanning, and pinning. 3. You can't secure what you can't inventory, so keep an AI-BOM. The SBOM idea, grown to cover models and datasets, and demand model provenance before you load anything. Next up is Episode 10, Secure AI Architecture and Deployment, where we stop inspecting the parts and start designing the system that wraps around them. If this helped, subscribe and drop a question in the comments. That's the Architecture Lens. I'll see you in the next one.